Hello, everyone. Welcome to my video on Alzheimer's disease, a type of neurodegenerative disease that affects the structure and function of the brain and memory. In this video, I will share with you some of the latest scientific papers that caught my eyes on this disease. Alzheimer's disease is characterized by the progressive loss of neurons and their connections, which leads to cognitive impairments such as memory loss, confusion, and dementia. Alzheimer's disease is caused by the accumulation of abnormal protein deposits called amyloid plaques and neurofibrillary tangles in the brain, which damage and destroy brain cells. Alzheimer's disease has no cure, but there are some treatments that can help manage the symptoms and slow down the progression of the disease. I will summarize the main findings and implications of these papers for you in this video. If you are interested in reading these papers yourself, you can find the links to them in the description box below. I hope you enjoy this video and learn something new about Alzheimer's disease. Please like, share, and subscribe to my channel for more videos on neurodegenerative diseases. Thank you for watching. Let's start. The first article is long, but it's important to know that. Cell primitive-based biomimetic nanomaterials for Alzheimer's disease targeting and therapy. Materials Today Bio, 2023. Scientific article about using cell primitive-based biomimetic nanomaterials for Alzheimer's disease, AD, treatment. Cell primitives are natural materials that come from living cells, such as cells themselves, extracellular vesicles, EVs, and cell membranes. Biomimetic nanomaterials are artificial materials that mimic the properties and functions of natural materials. The article reviews the challenges and strategies of using cell primitive-based biomimetic nanomaterials to deliver drugs to the brain and treat AD. The article explains that AD is a brain disorder that causes memory loss and cognitive decline. It is mainly caused by abnormal accumulation of proteins called amyloid-beta, A-beta, and tau in the brain. The article also explains that there are three main challenges in delivering drugs to the brain and treating AD. Low blood-brain barrier, BBB, permeability. The BBB is a protective layer that prevents most substances from entering the brain. Only a few drugs can cross the BBB and reach the brain. Limited targeting ability. Most drugs cannot target the specific areas or cells in the brain that are affected by AD. This reduces the effectiveness of the drugs and may cause side effects in other parts of the body. Instability and potential toxicity. Some drugs may change or degrade in the body, losing their therapeutic effects or producing harmful byproducts. The article then discusses how cell primitive-based biomimetic nanomaterials can overcome these challenges and provide better AD treatment. The article describes different types of cell primitives, such as macrophages, dendritic cells, neutrophils, mesenchymal stem cells, MSCs, and red blood cells, RBCs, and how they can be used to construct multifunctional therapeutic platforms. The article also describes various design strategies, such as genetic engineering, drug loading, surface modification, and membrane coating, to enhance the performance and functionality of cell primitive-based biomimetic nanomaterials. The article concludes that cell primitive-based biomimetic nanomaterials are promising tools for AD therapy because they have high biocompatibility, biosafety, stability, targeting ability, and drug delivery efficiency. The article also suggests some future research directions, such as improving the preparation method, increasing the multifunctionality, and evaluating the toxicity and safety of these biomaterials. The other article that caught my attention. Molecule reduces inflammation in Alzheimer's models. Picower Institute at MIT. Article context is about a new drug that may help people with Alzheimer's disease. Alzheimer's disease is a condition that affects the brain and causes problems with memory, thinking, and behavior. Summary of the main points. The new drug is called A11 and it works by reducing inflammation in the brain. Inflammation is when the body's immune system reacts too strongly and damages healthy cells. A11 targets a protein called Pu.1, which controls the activity of immune cells in the brain called microglia. In Alzheimer's disease, Pu.1 makes microglia produce too much inflammation and harm neurons, which are the cells that transmit information in the brain. A11 prevents Pu.1 from activating inflammatory genes in microglia, but does not affect its other function of making blood cells. This makes A11 safer than other drugs that lower Pu.1 levels. A11 has been tested in human cell cultures and in mice that have Alzheimer's-like symptoms. The results show that A11 reduces inflammation, preserves neurons, lowers amyloid and tau proteins, which are abnormal substances that build up in the brain of Alzheimer's patients, and improves memory and learning. A11 is not yet approved for human use and needs more testing before it can become a medicine. It could be used alone or together with other treatments that target amyloid. The researchers who developed A11 are from MIT and other institutions. They hope that A11 will provide a better option for people with Alzheimer's disease and other brain disorders that involve inflammation. And the last one article. Lecanemab in early Alzheimer's disease. The New England Journal of Medicine. The article is about a clinical trial of a new drug called lecanemab for people with early Alzheimer's disease. Alzheimer's disease is a condition that affects the brain and causes problems with memory, thinking, and behavior. The trial tested whether lecanemab could slow down the worsening of the disease by removing a harmful substance called amyloid from the brain. Amyloid is a protein that forms clumps in the brain and damages the nerve cells. The trial involved 95 people who had early Alzheimer's disease and were randomly assigned to receive either lecanemab or a placebo, a dummy treatment, through an injection every 2 weeks for 18 months. The trial also measured the levels of amyloid and other markers of the disease in the brain, blood, and spinal fluid of some participants. The results showed that lecanemab was better than placebo at reducing the decline in memory, thinking, and daily activities of the participants. Lecanemab also lowered the amount of amyloid in the brain and improved some other markers of the disease in the blood and spinal fluid. Lecanemab was generally safe, but it had some side effects, such as reactions to the injection, swelling or bleeding in the brain, headache, and falls. These side effects were more common in people who had a certain gene, ApoE4, that increases the risk of Alzheimer's disease. The trial concluded that lecanemab was effective and tolerable in people with early Alzheimer's disease, but more research is needed to confirm its long-term benefits and safety. Thank you for watching this video. I hope you learned something new about these articles. However, I want to remind you that this video is not a substitute for professional medical advice, diagnosis, or treatment. You should always consult your doctor or pharmacist before taking any medication or changing your dosage. Do not use this information to self-diagnose or self-treat any health condition. If you have any questions or concerns, please contact your healthcare provider immediately. Stay safe and healthy.